I want to deal with extra sums in inverse trigonometry. The first sum being 4 sin inverse of x plus cos inverse of x is equal to pi. You can write this as 3 sin inverse of x plus sin inverse of x plus cos inverse of x, so that this itself is pi by 2. So a 3 sin inverse of x plus pi by 2 is equal to pi. A 3 sin inverse of x is equal to pi minus pi by 2. A 3 sin inverse of x is equal to pi by 2. A sin inverse of x is equal to pi by 6. X is equal to sin pi by 6. A sin pi by 6 is sin 30, which is 1 by 2. So let's go to second sum. A cos inverse of x plus cos inverse of x by 2 plus root of 3 minus 3x square by 2 is equal to pi by 3. So can you see that there is a cos inverse here? If you can replace this as cos theta, cos inverse of cos can get cancelled. How do you do that? You have to write this as a cos inverse of 1 by 2 into x plus root 3 by 2 into root of 1 minus x square. Okay, so because root 3, when you, as soon as you see a root 3, 1 to root 3 is a triplet. Similarly, as soon as you see a 4 and a 3 or 5, this will be a triplet. A combination of this will be a triplet. Similarly, 12, 5 and 12 is 144 plus 25, 144 plus 25 and 13. This will be a triplet. These are the triplets that you can readily think of. And so then this, as soon as I see root 3, I know it's a triplet. I have to take it out and write it like this. And it has to be cos A, cos B, cos A, cos B plus sin A, sin B, where this is cos A and this is sin A. So you're going to write it like this, and where this is cos B, so that the cos inverse here will become cos of A minus B, and cos inverse and cos get cancelled. What did you assume A as? Cos inverse of 1 by 2. What did you assume B as? B is cos inverse of x. Cos inverse of 1 by 2 is cos 60, which is pi by 3 minus cos inverse of x. You already have this cos inverse of x, which you're going to bring it down. Cos inverse of x will get cancelled, hence answer is pi by 3. Let's go to third sum. Write in simplest form sin inverse of root x into root of 1 minus x square minus x into root of 1 minus x. You have to write it in simplest form, which is sin inverse of sin varnam. Therefore, you write as sin A. If this is sin A, this will be cos A. Because this root x is sin A, a cos A is root of 1 minus sin square A, so it will be root of 1 minus x. Okay, and this will be obviously, you want to get a sin, so sin A cos B minus cos A sin B. This is cos A, so therefore this is sin B. Therefore you understand that sin A itself is root x. A is sin inverse of root x, and a sin B is x. B is sin inverse of x. Substitution. So thus you get it as sin inverse of sin of A minus B. What does A stands for from here? Sin inverse of root x minus B is sin inverse of x. So this is how we can write it in simplest form. So let's go to next sum. The next sum for the day is the fourth sum, where it's given that tan inverse of root of 1 plus x square minus root of 1 minus x square by root of 1 plus x square plus root of 1 minus x square. This is similar to textbook sum, where it was the same sum, but it was root plus 1 plus x, 1 minus x, 1 plus x. Then we substitute x is cos theta, if you remember. So instead you say x square is cos theta, same format, x square is cos theta. Theta is cos inverse of x square. Substituting here, it's root of 1 plus cos theta minus root of 1 minus cos theta by root of 1 plus cos theta plus root of 1 minus cos theta. Tan inverse of 1 plus cos x is 2 cos square x by 2. So root 2 into cos x by 2, cos theta by 2, minus root 2 into sin theta by 2 by root 2 into cos theta by 2 plus root 2 into sin theta by 2. Root 2 throughout get cancelled, throughout dividing by cos theta by 2. 1 minus tan theta by 2 by 1 plus tan theta by 2, where 1 itself is tan pi by 4 minus tan theta by 2 by 1 plus tan pi by 4 tan theta by 2. You can write it like this. This itself is tan inverse of tan pi by 4 minus theta by 2. What is theta? It's cos inverse of x square. A pi by 4 minus cos inverse of x square by 2. That will be the answer for this. So if they say, okay, this is the sum, okay, yeah, that's enough. This is what it is. Let's go to next sum, which is fifth question. Show that a tan of half of sine inverse of 3 by 4 is equal to 4 minus root 7 by 3. I don't want a half of sine inverse. I don't want a 2 times or a half times. Then I'll assume this is 2 theta. Sine inverse of 3 by 4 itself as 2 theta. Sine 2 theta is equal to 3 by 4. And substituting here tan of half of 2 theta, which is just tan theta as your answer. How can you have tan theta? You know sine 2 theta so much. So we have a relationship between this and this. Sine 2 theta is 2 tan theta by 1 plus tan square theta. Sine 2 theta itself is 3 by 4, which is 2y by 1 plus y square. Cross multiplying, 3 plus 3y square is equal to 8y. A 3y square minus 8y plus 3 is equal to 0. Minus b plus or minus root of b square minus 4ac, 4 3 is 12, 12 3 is 36 by 2a. It's 8 plus or minus root of 28 by 6. It's 8 plus or minus 7 4s are 28. So 2 root 7 by 6, cancelling throughout with the two tables, is 4 plus or minus root 7 by 3. And that's one of the answers that you need to prove. 4 minus root 7 by 3. You will have two different answers, a 4 minus root 7 by 3 or a 4 plus root 7 by 3, but this is sine inverse. You know the sine value always sine inverse of radians, okay. Yeah, so we proved 4 minus root 7 by 3. Okay, so then that's about it. So let's go to next question. What about this answer? That this will be 4 minus, what is root 7? Root 7's value is 2 2s are 4. It's 2 point something. Therefore, you definitely, when you divide it by 3, it has to be, values should lie between minus 1 and plus 1. So this is the right answer, but this cannot be because it exceeds the plus 1 minus 1 limit. So then that's why this cannot be the answer. This is the answer. Let's go to next question. So whenever there's a half sine inverse, you have to assume sine inverse of 3 by 4 as 2 theta. Whenever there is a 2 sine inverse of 3 by 4, then you'll assume sine inverse of 3 by 4 as theta by 2. Because you want to eliminate the 2. That's the whole point. I hope you understand that. So let's go to next question, which is the sixth question, extra question of the day. So then let's do cos of 2 sine inverse of x is equal to 1 by 9. Solve for x. Solve for x. So solve for x. Okay, I don't want a 2 sine inverse. So I would assume sine inverse of x as theta by 2. Sine theta by 2 therefore will become x. So this will become cos of 2 into sine inverse of x itself is nothing but theta by 2. So you get a cos theta is equal to 1 by 9. Is it 1 by 9? Okay. Cos theta is 1 by 9. So theta therefore solve for x, right? And we got cos theta as 1 by 9. And you know that sin theta by 2 is what is x. And you can write cos theta as 1 minus 2 sin square theta by 2 is equal to 1 by 9. So 1 minus 2 x square is equal to 1 by 9. So 2x square minus 1 plus 1 by 9 is equal to 0. So 18x square minus 9 plus 1 is equal to 0. So you can solve it as 18x square minus 8 is equal to 0. 18x square is equal to 8. X square is equal to 8 by 18, which is 4 by 9. So x therefore is plus or minus 2 by 3. But it's given that if x is greater than 0, there's something called x greater than 0 has been given, and therefore x can be plus 2 by 3. Okay, so then whenever you see a 2 sine inverse, assume sine inverse of x is theta by 2 and substitute here 2 into theta by 2, cos theta will be 1 by 9. But you have to interrelate this and this. And a cos theta is 1 minus 2 sin square theta by 2 is 1 by 9. So this itself is x square. So you get a quadratic equation, not a quadratic equation, 2x square uh, minus 1 plus 1 by 9. So solve it and you get answer. Okay. So then let's go to next question. Is the sum number 7. Prove that cos of tan inverse of sine of cot inverse of x is equal to root of 1 plus x square by 2 plus x square. This is the question. So slowly see, this is sine of, you need it as sine inverse. You can convert into cot inverse as sine inverse by doing a triangle where it's adjacent by hypotenuse, cot. So it's adjacent by opposite, sorry. So it's x by 1, which is root of 1 plus x square. So you can convert into sine of sine inverse of 1 by root of 1 plus x square, because opposite by hypotenuse. So this will leave you behind with a tan inverse. And a tan inverse, you have a cos. You prefer cos of cos inverse. So this tan inverse has to be converted into cos inverse. So tan inverse is opposite, you write 1, adjacent you write 1 plus x square. By Pythagoras theorem, you will get hypotenuse to be root of 1 plus x square. Root of 1 plus x square the whole square. So it's root of 2 plus x square. So this will become cos inverse of adjacent by hypotenuse. Cos of cos inverse will get cancelled. You got what you want. Just how to convert a tan inverse into a cos inverse by doing a triangle. Very, very important. Okay. So let's go to next question. Okay, next question is 8th question. Solve for x. A cos inverse of x plus sine inverse of x by 2 is equal to pi by 6. How to solve for x? Which means right hand side has been given. Okay, sine inverse of x plus sine inverse of x by 2 is equal to pi by 6. No, let's omit this sum. This sum is not there. Okay, so let's do something else. Okay, let's go to an 8th sum. 3 tan inverse of x plus cot inverse of x is equal to pi. You can write this as 2 tan inverse of x plus tan inverse of x plus cot inverse of x is equal to pi. So this itself is pi by 2. A 2 tan inverse of x plus pi by 2 is equal to pi. A 2 tan inverse of x is equal to pi minus pi by 2. A 2 tan inverse of x is equal to pi by 2. A tan inverse of x is equal to pi by 4. A tan pi by 4 is what is x, and therefore it's equal to 1. So such an easy sum. So let's go to next question, which is the 9th question, which is sine of tan inverse of 0.75. And you have a 2 here. You don't want a 2 tan inverse. So therefore you'll assume tan inverse of 0.75 as theta by 2. When you do that here, this will become, so then tan theta by 2 is equal to 0.75. Kattam potu vechiko. Sine of 2 into theta by 2. The answer is just sine theta. And you need to interrelate these two. And sine theta is 2 tan theta by 2 by 1 plus tan square theta by 2. And this is like 2y by 1 plus y square. And tan theta by 2 is value. Y is value, 0.75. 2 into 0.75 by 1 plus 0.75 the whole square will give you what is your sine theta. You just have to solve this. You understand? So then you don't want the 2 tan inverse. So you assume this is theta by 2. Tan theta by 2, therefore 0.75. What is 0.75? 75 by 100. Which is 25 3s are and 25 4s are. It's also 3 by 5. So sine theta is 2 into 3 by 4 plus 1 by 3 by 4 the whole square. So hence you can solve sine theta itself. What is you have to solve for? Write the value of. So you just have to write the value. Okay. The sine theta is the answer, and you have to get what is sine theta, and you got it. You just have to solve this. It's 2 into 3 by 4, which is 6 by 4 by 1 plus 9 by 16. 6 by 4 plus 25 by 16. So this is 4 4s are 16. 6 4s are 24 by 25 is what is sine theta. They're just asking for write the value. Just you get the left hand side's value. Left hand side got simplified like this, and you got left hand side value to be this. Okay. Next question. is let's take this sum, which is sum number 10. If tan inverse of x plus tan inverse of y is equal to 4 pi by 5, right? What is cot inverse of x plus cot inverse of y? And you know pi by 2 minus cot inverse of x, and this will become pi by 2 minus cot inverse of y is equal to 4 pi by 5. So then it's pi by 2 plus pi by 2, which is pi minus cot inverse of x plus cot inverse of y is 4 pi by 5. So taking this to that side and this to this side, as pi minus 4 pi by 5 is what is cot inverse of x plus cot inverse of y. So it's pi by 5 is what is cot inverse of x plus cot inverse of y, and they have asked you to find that value only. Okay, find the value of cot inverse of x plus cot inverse of y. Next, so let's go to 11th question. The 11th question is find the value of tan of half of cos inverse of 2 by root 5. I told you, you don't want a half. So in that case, a cos inverse of 2 by root 5, you'll assume it as 2 theta. Thus the cos 2 theta is 2 by root 5. And when you substitute here tan of half of 2 theta, it will just be tan theta, and you have to find a relationship between these two. And you know cos 2 theta is 1 minus tan square theta by 1 plus tan square theta. And a cos 2 theta itself is 2 by root 5 is equal to 1 minus y square by 1 plus y square. Just cross multiplying, you can get the value of tan theta, because you assume tan theta to be y. Yeah. So then 2 plus 2y square is equal to root 5 minus root 5y square. Consolidating y square is 2 plus root 5 is equal to root 5 minus 2. Y square is root 5 minus 2 by 2 plus root 5. And then therefore y is equal to root of this. Y is equal to square root of this. Okay, these are the practice sums. I'm not saying this is going to come, but this is to enable you to understand that half of cos inverse varakudadu. How do you do that? How do you proceed in that case? How do you find a relationship between LHS and RHS and solve it? That's the whole point. Okay, so you have to solve for tan theta, and that's nothing but y, which is itself root of root 5 minus 2 by root 5 plus 2, and you can rationalize and write the answer. That's different, but the process of doing the sum is what I want you to be clear with. So let's go to 12th question. The 12th question, find the value of tan of sin inverse of x plus cos inverse of x by 2. And can you see this is like sin inverse of x plus cos inverse of x itself is identity pi by 2. So it will become pi by 4, and tan pi by 4 is nothing but 1. So that's what it is. Okay, and that's an identity which you have to identify. So next is the 13th question, which is y is equal to sin inverse of 6x minus 4 into root of 1 minus 4x square by 5. So y is equal to sin inverse of, you can write it as, can you see that you can take the 2 common? Take a 2 common, it will become 3x minus 2 into root of 1 minus 4x square by 5. I am trying to see if there is any triplet, if I am getting any triplet, okay. And you know 3, 4 and 5 forms a triplet. 3, 4 and 5 forms a triplet. So can I write it as sin inverse of 2 into 3 by 5 into x minus this has got to be but I'm getting, if I take the 2 out, I'm getting this 3x, but I'm getting this changed to 2. See, this is a very important sum where I'm trying to convert it into triplet. It's not happening because I'm getting a 2 by 5 into root of 1 minus 4x square, and a 2, 3 and 5 doesn't make a triplet. So then therefore I'm showing you how you get stuck with the sum, and then how you proceed. Okay, you have to assume y is equal to sin inverse of, this is 2 into 3x or a 3 into 2x. Let's try that. A 3 into 2x by 5 minus a 4 into root of 1 minus 2x the whole square by 5. So then y is equal to sin inverse of 3 by 5 into 2x minus 4 by 5 into root of 1 minus 2x the whole square. Now this can be converted as sin inverse of sin A cos B minus cos A sin B, and I've got a triplet. So this, how do you take that? You can't take the 2 out like I did first. If you do that, you're not ending up getting a triplet, because a 3, 4 and 5 is what forms a triplet. So then therefore it's y is equal to sine inverse of sine A minus B. Sine inverse and sine will get cancelled. What is A? Can you see sine A is equal to 3 by 5. A is equal to sine inverse of 3 by 5. And cos B is equal to 2x. B is equal to cos inverse of 2x. So then it's sine inverse of 3 by 5 minus cos inverse of 2x. And that will be your y's value. Okay, if you're asked to simplify it, this is the way you would simplify. Okay, so that's the way you have to simplify. Hope you're clear. Okay, so let's go to next sum. It's the 14th question. 14th question, which one can I do? Like cos inverse of x square minus 1 by x square plus 1 plus tan inverse of 2x by x square minus 1 is equal to 2 pi by 3. You have to solve for x. Okay, solve. So you know that this itself, you have to switch it like this, so that you get 2 tan theta by 1 minus tan square theta. And when you switch it, you will get a negative sign out, and it's 2x by 1 minus x square. And tan inverse of minus negative argument, cos, secant and cot alone is pi minus. So it's minus tan inverse of 2x by 1 minus x square. Now on substituting x's, you know this itself is 2 tan inverse of x. 2 tan inverse of x. And this itself is, it has to be 1 minus x square again. So you take a negative sign out, a cos inverse of minus of 1 minus x square by 1 plus x square. And cos inverse of minus is pi minus cos inverse of 1 minus x square by 1 plus x square. And this itself is 2 tan inverse of x again with a negative sign, because there's negative sign, and a pi minus. So it's pi minus 4 tan inverse of x, which is equal to the right hand side, because this solves sum 2 pi by 3. So then taking the tan inverse to the other side, pi minus 2 pi by 3 is equal to tan inverse of x. So then therefore it's pi by 3 is equal to tan inverse of x. X is equal to tan pi by 3, tan 60, and tan 60 itself is root 3 by 2. Tan 60 itself is root 3, tan 60 is just root 3. So thus you can solve for x. Okay, then I can also show you another sum, like 15th sum. A tan inverse of a 6x minus 8x cube by 1 minus 12x square minus tan inverse of 4x by 1 minus 4x square. You have to show that this is equal to tan inverse of 2x. This like you have to write it as 3 tan theta minus tan cube theta, 3 tan theta, 3 2 6 minus tan cube theta by 1 minus 3 tan square theta, where I am treating 2x as tan theta. Theta therefore is tan inverse of 2x. So that this resembles 3 tan theta minus tan cube theta by 1 minus 3 tan square theta, which is tan inverse of tan 3 theta. 3 theta is the answer, which is 3 into tan inverse of 2x. So I've just solved only this part. Okay, now I have to solve the next part, which is tan inverse of the second term is tan inverse of 4x by 1 minus 4x square. You have to write as tan inverse of 2 into 2x by 1 minus 2x the whole square. Again 2x is tan theta. So therefore this will become tan inverse of 2 tan theta by 1 minus tan square theta, which is tan inverse of tan 2 theta, which is just 2 theta, which is 2 into tan inverse of 2x. This is 3 into tan inverse of 2x, and this is 2 into tan inverse of 2x. And so it will become 5 into tan inverse of 2x. I hope I'm saying the right thing. Let me see. So then tan inverse of, okay. So the left hand side therefore is 3 into tan inverse of 2x plus 2 into tan inverse of 2x. And what is there at the right hand side? It's a show that, is it? So I'm getting 5. There has to be a negative sign. Yeah, there is a negative sign. So when you subtract these two, you'll just get tan inverse of 2x. And that tallies with what right hand side. So how to write this as 3 tan theta minus tan cube theta is where the trick is all about. So if you can solve these questions, And there are a lot more extra sums that I can give. Probably I'll do, this is a level 1 video. It's a basic extra sums in inverse trigonometry, which is very, very basic. You can call it as level 1. Okay, so I'll make a separate video for difficult sums in inverse trigonometry, which only PS senior students can try. Other schools, I think they'll be not going to that level. Okay, so other students may try, but out of your own wish. Okay, so this is a inverse trig extra questions video 1.